let's look at the properties of exponential functions, right? So we have fx equals a to the x. Now we graphed a to the x and we found out that based on the value of a, it's either an increasing function or a decreasing function, right? So let's look at case 1 here. When a is greater than 1, and then let's do a comparison with the second case where a is between 0 and 1. Okay, so as we had seen earlier, in this case, the graph sort of looks like that. Okay, and in this case, the graph looks like that. It's so, like I said, it's if you reflect this over the y-axis, you're going to get case 2 here. So what's the domain? The first thing we're interested in, what is the domain of this function? So as I extend x in the negative direction, the function keeps going, right? And there's no bound on the function, so it keeps going up. So remember, the function never touches or crosses the x-axis, right? So in case of domain, there's no restriction. I can go all the way to the left, or I could go all the way to the right. And so that's going to be negative infinity to positive infinity. Same with this one. My domain is going to be negative infinity to positive infinity. Okay, my range what's my range? Like I said, it can never touch the x-axis or it can never go below the x-axis. So my y values will never be 0 or my y values will never be negative. Right? They're only going to be positive. So that means it's going to be between 0 and infinity. That's all positive real numbers. Same with this one, right? It doesn't touch or go below the x-axis. So it's going to be 0 to infinity. Okay. Now, in this case, if a is greater than 1, we call it an exponential growth, right? So in this case, I get an exponential growth, where a is called the the growth factor, right? It's an increasing function, and I have a growth factor. Whereas here, I get an exponential decay or an exponential decrease, and we call a is the decay factor. Okay. Also notice that I have a horizontal asymptote here. So my horizontal asymptote is the line y equal to 0 or the x-axis. Same here, I have my horizontal asymptote y equal to 0 or the x-axis. Okay, and notice one more thing, that both these functions cross the y-axis, and they actually cross the if you remember your table, they cross the y-axis at the point 0, 1. Right? So I have a y-intercept of 0, 1 in both cases. Okay? So you will need to know this in order to work with exponential functions, especially if you're graphing and solving equations. All right, so take a look at these, and these are the properties of exponential functions. Okay, so let's take a look at this example here. So what we want to do is, we have an exponential function of the form c times a to the x. Now know that it's not in parentheses, so the x doesn't apply to c, it's just to a, right? So c times a to the x. And we know two instances of this function. At 0, that function value is 3, and at 2, the function value is 75. So I want to find this exponential function. It's just another way of saying I want to find what the value of c and a are, right? So what is c and what is a? So let's write that function down again. I have f of x equals c times a to the x. Okay, so I know f of 0 equal to 3, which means that c times a to the 0 is equal to 3. Now I know that a to the 0 is equal to 1, which means c times 1 equal to 3, which means that c equals 3. Right? So I'm going to go ahead and plug that back in my equation, and so now I have f of x equals 3 times a to the x. So now I just need to find the value of a. Well, I still haven't used my second bit of information here. So I know that f of 2 equals 75, which tells me that 3 times a squared equals 75. Now how do we solve this? Well, divide by 3, so that gives me a squared equals 25, right? And then what is a? Well, a is equal to 5. Now, technically, a is equal to plus or minus 5, but remember what we said for exponential functions, a cannot be negative, so for us, a will be equal to 5. And so our function is f of x equals 3 times five to the x.